There are several upsampling methods. Among many methods, in this video clip, I want to highlight the transpose convolutional method. So the convolution layer, the conv layer, basically what the convolutional layer doing is, from the input signal, the conv layer defines several filters like this or this or this, and then take inner product between each local part of your input signal and then each filter. So the inner product between filter and local information will give you some number like 1, 0.5, 0.3, 0.7 for each area, which indicate how much this shape of information is there. The inner product indicate how much such shape inside the area. So from this value, you can understand the shape of input signal, and you can extract some information from the input signal from the given filters. So the conv layer basically is extracting the information from the predefined filters or the filters learned from your training process. On the other hand, transpose convolutional filter is doing this from the value like 1, 0.5, 0.7, 0.2. We restore the input signal. So how can we do that? Again, using filter, looks like this, this, this. For each filter, we define the value or we obtain some value. And then take product between this value and this. 1 times this signal, 0.5 times signal, 0.7 times signal, 0.2 times the signal or the value. Okay, for this filter as well. From the input signal vector and from filter shape, you add the filter shape as much as the input value. And then sum up all the signal value comes from product between your input vector and the filter shape, which basically can give you some signal, right? And that have the high dimensional structure compared to the input structure. Okay, basically the filters represent some frequently appear patterns. So from the abstracted value and the predefined very frequent patterns, you can restore almost every possible signals. Okay, so with this process, you can increase the signal dimension, so which is kind of upsampling, and from well-aligned the conv filters and the transconvolutional filters, you can compress any signal very well, and you can restore the signal very well. But of course, you do not manually define the conv filter and transconvolutional filters. The filter values or filter shape will be obtained from your training process. They are parameters, and you define loss functions, and the backpropagation gradient descent rule will give you very nice convolutional filter shape and transconvolutional filter shape. The transconvolutional filter is a very important concept because many variational autoencoder and GAN structure, they really frequently use transconvolutional filter to draw some new image from very small dimensional latent vectors. Okay, and so I recommend to read some online materials which describe why transconvolutional filters is named transconvolutional, which is actually mentioned in the CS231 and Stanford online course. So I recommend to read some papers as well, because to understand each concept more accurately, you have to practice. You need to write down the matrix shape for convolution and matrix shape for transconvolutional filters. When you change your input dimension to 1D vector, and when you change your output also 1D vector instead of 3-dimensional tensor structures.